In this podcast, we'll go over matter, its properties, types, and the measurement of matter. So let's start with the basics. What is matter? Matter is anything that has a mass and occupies space, meaning it has mass and volume. How many states of matter are there? I know you're all aware of the three states of matter: solid, liquid, and gas. Solid state has definite shape, definite volume. Liquid state does not have definite shape but has definite volume. And gaseous state does not have either definite shape or definite volume due to very weak intermolecular forces. But what are plasma and BEC? Plasma state is a very highly energized and charged state of matter where matter exists as ions. Plasma state is short-lived and is not found naturally on Earth. It is found naturally on the upper atmosphere of the Earth but not on Earth. BEC is a name that goes for Bose-Einstein condensate, and as the name suggests, the discoverer of this state were Bose and Einstein, and in this state occurs nearly absolute zero temperature, so it is highly cooled, and at that temperature the bosons or subatomic particles are present in a very low quantum energy state. You can read up more about these on the internet, but it's just good to be aware that there are two more states of matter now. So let's go to the next point, which is how many types of matter is there? Generally, there are three types of matter: elements, compounds, and mixtures. Elements are the building blocks of chemistry, and this is what you see on your periodic table. Currently, we have 118 elements discovered: hydrogen, helium, lithium, beryllium, boron, nitrogen, carbon, fluorine, neon, and so on. These are all elements. Elements make up compounds, or elements chemically combine to form compounds. Compounds have elements present always in the same mass ratio. For example, in water, which is a compound, it's made up of hydrogen and oxygen, and hydrogen and oxygen are always present in the mass of 1 to 8. That is the mass ratio, and this is called law of constant composition. So as elements combine to form compounds, they combine in the same ratio always. Mixtures are a combination of two or more substances, generally compounds. So you throw a couple of compounds together through a physical association. They kind of stay together as a mixture, and hence separating the mixtures is rather easy. You can separate it in its components. Separation of compounds, however, is not so easy, because if you recall, elements combine chemically to form compounds. So if you want to break up the compounds, you have to use rather harsh means like passing electric current, which is called electrolysis. So you can break up water into hydrogen and oxygen gas by electrolyzing it, but other simpler means will not break up water into hydrogen and oxygen. Now we're going to be looking a little later in the podcast on the separation techniques for mixtures and the properties of matter like physical, chemical, intensive, extensive. But let's start with classification of matter. So matter, first of all, is classified based upon its uniformity. If you were to take spoon after spoon of that sample, is the matter uniform? If it is not uniform, then we call it a heterogeneous mixture, meaning its composition is not uniform throughout. If the composition is uniform throughout, then we call such a mixture as homogeneous mixture. An example of heterogeneous mixture that you see in your day-to-day life is Lucky Charm cereal, where in every bite you may get different amount of marshmallows. An example of a homogeneous mixture could be sugar syrup, where you mix sugar in water and that sample has the same amount of sugar per teaspoon if you scoop it out. Now, homogeneous mixtures can be of two types. It could be pure substances, which could be either element or compounds, or it could be a mixture. And what decides if it is a pure compound or mixture is, does it have a variable composition? And what does variable composition mean? It means that if you make that substance over and over again, do you get the same ratio of elements in that compound or in that mixture, or is this ratio different? Let me explain like this. So you decided to make sugar syrup for your lemonade. One time you added 4 teaspoons in a cup of water and stirred it nicely. Now that's a homogeneous solution, right? Because if you take spoon after spoon, it is same composition. But you decided your lemonade got too sweet. So next time when you made sugar syrup, you only added 2 teaspoons in a glass of water. And you mixed it real well. Throughout this glass of water, composition is the same, but is your sugar syrup's composition the same from the last time you made lemonade to this time? Answer is no, because you had 4 teaspoons of sugar in a cup of water last time and 2 teaspoons of sugar in a cup of water this time. So it has variable composition. But if you were to cook water, H2O, you'll always have to mix hydrogen and oxygen in a 2 to 1 mole ratio or 1 to 8 mass ratio. So pure substances do not have a variable composition, but mixtures do have a variable composition. Then pure substance can be of 2 types as well. Elements and compounds. Elements cannot be broken down in any smaller units because they're the smallest unit of matter, while compounds can be broken down in smaller units based on very harsh chemical means, while the mixtures can be separated by physical methods. And we'll go over separation of mixtures right here. The first and the easiest is the hand separation, and I bet you all have used this technique while eating your M&Ms or jelly beans, or Skittles. You pick up your favorite color first, and that's exactly what is hand separation. Hand separation can be used for a homogeneous or heterogeneous mixture. The requirement for this is that the particles should be visible by eye and they should be distinguished from each other either based on color or texture, so you can hand separate things. The second mode of separation is called filtration, and we often use this technique in chemistry. In filtration, you use a sieve, and our sieve is called a filter paper. A filter paper is like a round disc of a porous paper, and you generally separate precipitate using this method. Precipitate is a solid that's present in a liquid, so you stir the solution real good, and when you pour it down, the larger particles are held on top of the filter paper while the liquid passes through. So in this case, the red precipitate stays on the filter paper while what you get here is called the filtrate. So this is a sieve technique. Basically, filter paper has small holes which only let smaller size particles pass through and the bigger size particles stay on top. Filtration generally is used to separate heterogeneous mixture, because think about a homogeneous solution like a sugar solution or a salt solution. That's going to go right past through because salt and sugar particles are not big enough to be held on top by filter paper. Separating funnel is used to separate out immiscible liquids. This term means like oil and water or 2 liquids that don't mix with each other. To use this, you have a mixture, you shake it and let it sit. The lighter layer separates on the top, which in this case is oil, lighter layer, and the heavier layer settles at the bottom, which is water in this case. And then you put a beaker under it, you open the stop cork and you let it pass, then you close it, you discard little layer in between. There is mixing in this layer, you don't want mixing, you discard that and put another beaker and separate out your top layer. Next method of separation is called centrifugation. Centrifugation separates particles of different size or different mass, not size, I take it back, of different mass, because it is based upon centrifugal force. Centrifugal force is a force when something is moving in a circle, it pushes it to the side. So if a particle has larger mass, there is greater centrifugal force and it settles at the bottom. The heaviest particles after centrifugation will settle at the bottom and the lighter particles will settle on the top. So this is another good PowerPoint link here to go and check how centrifugation works, but this is a pictorial representation. You have mixed mass particles. You see the heavier particles settle at the bottom, lighter ones settle on the top, and they form like a gradient based upon masses. And you can separate each layer by finding a proper solvent to dissolve it in. So each layer dissolves in a particular solvent, and then you pour it down, then you add another solvent to dissolve next layer, and so on. And this picture here is of a micro or small centrifuge that typically high school laboratories have. Next separation technique is called distillation, and in distillation generally you use it to separate homogeneous mixtures that have different boiling points, like methanol, ethanol, and isopropanol. Any type of alcohols can be separated. Water alcohol mixture can be separated by that. You can even use this to separate salt from water, but it's a rather expensive method. If you're not in a rush, you can just let it evaporate and salt will stay at the bottom and water will just evaporate, but you can always use distillation to separate that as well. How distillation works is, first of all, you take the mixture in the distilling flask and you heat it up. When you heat it up, the lower boiling liquid boils off first and goes here through steam via a condenser. The condenser cools the steam and that steam turns to liquid and gets collected here. While something is boiling, the temperature stays constant. And you see, as long as the temperature is constant, the first substance is being collected here. When the temperature starts rising again, you remove this flask, put another flask in there to collect your second liquid. In this case, where you have salt water, only water will boil off and salt will remain in this flask. If you had two liquids, then first liquid, lower boiling liquid will boil off, then the higher boiling liquid will boil off. This is a great animation to look at distillation and how it works. Chromatography is a technique whereby it's generally used to separate out inks in a mixture of inks, and you use a mixture and you use a stationary phase, which in this case is a paper, and a mobile phase, which in this case is either water or a solvent. And depending on the affinity of inks in the mixture to solid or stationary or mobile phase, it may move or may not move. So here you see this blue spot has moved, so you can say that it has more affinity for the mobile phase versus this purple that has decided not to move much, so it has more affinity to stationary phase. And you can identify these different spots by calculating RF value, which is like their fingerprint and tells you which substance it is. Now we're going to switch tracks and talk about the composition of compounds. And there are two laws that came for the compounds. First is called law of constant composition, and second one is called as law of multiple proportions. Law of constant composition tells you that elements combine in the same mass ratio in a pure compound. It means that in pure water, if you have pure water, whether you have it from US, Canada, China, or any part of the world, hydrogen and oxygen will combine in a 1:8 mass ratio. And I'll let you ponder over these questions, but that is law of constant composition. Now, law of multiple proportion says when two elements combine to form more than two compounds, like hydrogen and oxygen make water and H2O2, then with the same mass of one element, the mass of the other element that combines in small whole number ratios. For example, in H2O, there is 2 grams of hydrogen combining with 16 grams of oxygen. Here, 2 grams of hydrogen is combining with 32 grams of oxygen. So this law states that the ratio of 16 to 32 is 1 to 2, or small whole number. So the amount of oxygen that's combining with 2 grams of hydrogen is present in small whole number. So that is law of multiple proportions. I would suggest that you guys do this practice problem and see if you have a good understanding of law of multiple proportions. This is a good animation to look over law of multiple proportions. Now we are on to measurement part of the matter. I know this podcast is getting long, but I rather have a longer podcast for this chapter than to break it into shorter ones. So I'm going to continue. Measurement is very important for chemists and chemistry, and to make our measurement standard across all the countries, we have a SI system, or system, La System International, or international system of measurement. In international system of measurement, we have certain base units. We have mass unit as kilograms, length unit as meter, electric current for amperes, and temperature in Kelvin. Kelvin is the SI base unit, and amount of substance as mole. You must know these units. And then for the SI units, we also have certain prefixes that we can add to these base units to make the units bigger or make the units smaller. So these three units, this unit, kilo is a prefix that will change a base SI unit to a larger unit. If you put kilo in front of gram, or if you put kilo in front of meter, it becomes 10 to the power 3 value. While these are all smaller quantities. And you can see I have only one big prefix here, but a lot of smaller ones, because we deal with atoms which are generally smaller quantities. But for SI units, you have prefix on either end. You have prefix that make your unit bigger all the way to 10 power 9, 10 to power 12, and you have prefixes that make your unit smaller all the way to 10 power negative 12. The idea of this is when you're measuring something really big, like Earth's diameter, if you start doing it in a small unit like meter, your value will be crazy large and you'll have a huge percent error. So you need to use a larger unit. And how can you change a unit into larger unit in SI system? By using a big prefix. If you use a prefix that changes your unit into 10 power 12, then that will be a better unit to use for Earth's diameter. If you have to measure diameter of an atom, you know an atom is very, very small. Now if you use a large unit for that, your results will be very wrong. So you need to use a small unit. So the beauty of SI units is you can, by using prefix, you can change it to a large or a small unit depending on what you are measuring. I would suggest that you remember these abbreviations and their values. Now moving on to measurement, chemists are always measuring, and in measurement there's always uncertainty. No matter how carefully you take the measurement, there are random and systematic errors. Random errors are beyond your control, like human errors, and systematic errors are there present because of the equipment involved that you're using to measure something. Now, uncertainty in measurement decides how accurate your measurement is. And we'll look at it, take a deeper look at uncertainty, but let's first get a few terms right here. Precision, accuracy. Precision and accuracy generally are used interchangeably, but they are two very different terms. Precision means how close the measurements are to themselves, almost like the spread of measurements. If you're measuring your mass, my actual weight might be 140 pounds, but every time I step on scale, it shows me 160, 161, 162. I'll say that my measurement is very precise because the spread of my measurement is rather narrow. But am I accurate? Am I close to my real value? No. So accuracy is when your measurement is close to your actual value, and precision is when the spread of the measurement is not too much. Now, kids like to get a quantitative value for how spread is to spread or how accurate. Generally in chemistry, plus minus 5% for both accuracy and precision works. Significant digits now. Sig-figs, so significant digits are digits in a measurement that matter. Significant digits really show the accuracy of a measurement. Significant digits include all certain digits plus the first guessed number. How do you determine significant digits? Well, if you're taking the measurement using an equipment, it's rather easy. You look at all the numbers that you certain plus take the first guess number. But if you are given a already measured value, how do you figure out its significance? I use Atlantic Pacific rule for that. So this is Pacific Ocean for USA and this is Atlantic Ocean. So P also is for present, means a decimal present. And A is for absent, meaning decimal absent. So when you're given a number like 807, you first look, is there a decimal present? No. If it is absent, then you start from the Atlantic side, from the first non-zero number and count every number after that. So it has 3 significant digits. How about 1.005? Does it have a decimal present? Yes. Then you start counting from Pacific side, from the first non-zero number and count everything. So it has 4 significant digits. How about 1? Has 1 significant digits. How about 1.0? It has 2 significant digits. How about 1.00? It has 3 significant digits. So is 1.0 and 1.00 same measurement? No. Lot of times in your labs you will not take care of your significant digits. What is the difference between a measurement of 1.0 and 1.00? 1.00 tells you that your measurement is accurate to 100th, while this is accurate to the 10th place, and this is only accurate in the 1st place. So which is your most sensitive or best measurement? 1.00. You have used a very good equipment or apparatus for this measurement. So these are not the same measurements. 1.00 shows that your measurement is very accurate. Significant digits, I know, are emphasized a lot in the first year chemistry, but in AP chemistry, because you get plus minus 1 for significant digits, you can always write 3 significant digits and generally you are right. However, let me emphasize that it's very important to understand the concept behind significant digits, because significant digits tell you the accuracy of your measurement. And if there are exact numbers that are counted and not measured, they have unlimited amount of significant digits, or they never limit your calculations, because there is no uncertainty in counting. There is uncertainty in measurement, but there's no uncertainty in counting. Similarly, a number of 7,000 and 7,000 with a dot are 2 very different measurements. 7,000 means that this is a very inaccurate measurement. Only in thousands place you have some form of certainty in your measurement. Here you have certainty in the ones place, because all of these become significant. So please keep that in mind as you are thinking of significant digits. If you need more practice, this is a great link for practice. So what is the purpose of significant digits? First of all, it shows you the accuracy of your measurement. Whatever you're measuring or was measured, how accurate was that measurement? Now, calculating with significant digits. So what happens in chemistry? Let's say you're trying to find density of water, right? You'll take its mass using probably a balance, you'll take its volume, probably using a measuring cylinder, and then you'll have to do a division. So you're constantly adding, subtracting, dividing, or multiplying significant digits. Now, significance of each measurement is different. So how do you account for difference in the significance of each measurement? Well, the basic guiding principle here is you cannot be stronger than your weakest link. So if you've taken 3 different measurements, one using a very sensitive equipment that goes to 3 places of decimal accuracy, and one using a beaker that probably is accurate only to plus minus 5 ml. Your ultimate accuracy will be that of the beaker, because that's the least accurate. So in a series of measurements, your least accurate equipment becomes your bottleneck. It is an overkill than to use a very sensitive equipment with a less sensitive equipment, and if you have to add those or divide those or multiply those measurements together, it does not make sense to do it. So what are the rules for calculating with sig figs? When you're adding or subtracting, then you go to minimum place of decimal if there are decimals present in a number. If not, then you go to the least place of accuracy or the last place of accuracy. Here, in this measurement, you know that you are sure to the hundredths place. And here you are sure in, in the third place, right? Here you're sure to the 40s. So you will be rounding to the hundredths place and not to the tenths place, because even though tenths place is more accurate, you have to round to your least accurate measurement, which is to the hundredths place here. So it will be 6.22 times 10 power 4 or 62,200. For multiplication and division, there's another set of rules which says that you go to total minimum number of sig figs. So here you're multiplying 4 sig figs with 3, so your answer will have 3 sig figs. Now what if you were doing a multiple step operation, like you're subtracting 3 minus 1.0 divided by 5? So you will first look at your first step. So if you subtract from 3 1.0, you'll get 2.0 because you go to minimum place of decimal, right? However, you don't write it, but just keep in mind that you'll get two significant figures at the end of this calculation. Do not round at each step, because each step rounding incurs error and you want your result to be most accurate. So without rounding, keep track of your significant digits, and you have two significant digits divided by 1, so your answer will have one significant digit, a significant figure. So that's how you do calculations. You can see the rules for logs and anti-logs. I'm not going to emphasize much on that because it is not worth your while to be spending time on that for now. We will go as a rule in class to 3 significant digits always, not 3 places of decimal, guys, 3 significant digits. Now, how do you round it? You know, if it is greater than 5, you round up. Less than 5, you keep it the same. If 5 is followed by a non-zero number, then you round up. If it ends in 5, you are supposed to round it to 5, and the next number to it, the previous number, is odd, then you round up. And if the previous number is even, then you keep the same. The idea in rounding is that it's law of averages. Half the time you're rounding up, half the time you're leaving the same. So ultimately in your calculation, the effect of rounding or the inaccuracy incurred by rounding will be minimized by law of averages. Then there is dimensional analysis. This is a method which is used for converting between units, one unit to other. You start with what's being asked of you, and then you use conversion factors, and then you write your answer. The significant digits in a factor label method or dimensional analysis are determined by the very first quantity that you use. There are 3 significant digits here, so your answer will have 3 significant digits. I'm not going to elaborate much on this dimensional analysis because you already must be masters of it by the time you reach AP Chemistry, because you've done it so much in your first year chemistry course. Last part of this podcast is going over the properties of matter. Matter has physical and chemical properties. Physical properties can be observed without changing a substance's chemical composition, like its solubility, its boiling point, melting point, mass, volume. All of those are physical properties. Its texture, color, smell, anything that you can observe without changing its chemical property. A chemical property can only be observed by changing its chemical composition, or you have to kind of carry out a chemical reaction. For example, does something burn? Is it corrosive? Does it react with acid? All of these are classified as chemical property. Then there are also intensive and extensive properties. Intensive properties do not depend upon amount of matter, like boiling and melting point. So whether you boil a cup full of water or a bucket full of water, it'll always boil at 100 degrees. A cup full will boil faster, And a bucketful will take a little bit longer to boil, but at boiling the temperature will be 100 degrees. So that's boiling point is an example of intensive property. Extensive properties depend upon the amount of substance like mass, volume, energy. The more the matter, the more will be the mass, right? So these are the extensive properties depend upon the amount of substance. And with that, we end this this podcast for chapter 1, which is matter and its property. Thank you for listening.